So today we're going to be looking at radical equations and graphs, so like transformations from our parent functions. So first, when we're solving radical equations, your first step is always to isolate the radical on one side, then raise each side to the power of the index. So if you have like cube root, raise everything to the third power. Square root, you're going to raise everything to the second power, and so on. Then you solve your equation, so that's going to get rid of your radical, and you need to check for extraneous solutions. So for example, in this one, we want to get this square root by itself first. So imagine if this was like negative 4x plus 18 equals negative 2. You would start out by subtracting 18 to the other side and then divide by negative 4. So we're going to do that same thing to get the square root by itself. So if we subtract 18, we're left with negative 4 times the square root of 43 minus 3x equals negative 20. And we're going to divide by negative 4. So the square root of 43 minus 3x equals positive 5. Now we always need it to be equal to a positive number because the square root of something can't be equal to a negative number. Once it's by itself, raise it to whatever this index is. In this case, it is 2. So that's going to cancel out our radical, and you're just left with what's underneath it. And then 5 squared is 25. I'm just going to rewrite it up here. So then now it's just a regular equation to solve. We're going to subtract 43 from both sides. So we get negative 3x equals negative 18. And we're going to divide by negative 3. So x is positive 6. So now you want to check for an extraneous solution. So if you have like the square root, so remember cube roots can be negatives, but square roots can't have like a negative under there. So since it's square root, we need to make sure it's not going to be a negative under there. So if we plug in the 6, it's the square root of 43 minus 3 times 6. 43 minus 18 will be positive, so that answer works. Next, we're going to look at the graph. So we're going to start out by looking at the parent functions. So for example, the parent function for a square root would be f of x equals the square root of x. For a cube root, it would be the cube root of x, and so on. So if we think about this, for the square root of x, the square root of 0 would be 0. The square root of 1 is 1. The square root of 4 would be 2. Square root of 9 would be 3, and so on. So we don't have negatives for the square root, so our function just looks like this. So that is our parent function. And then for cube root, it's going to look a little different because we can have negatives. So for cube root, it's still 1, but it can also be the cube root of negative 1 is negative 1. The cube root now of 8 is 2. And the cube root of negative 8 would be negative 2. So the parent function for the cube is going to look more like that. It goes through both sides. So now we're going to look at what our transformations could be from these to help us graph. So it's kind of similar to when we talked about transformations when it was in vertex form of parabolas. Pretty much the same thing. So your h, the one that's under the square root, is going to move it horizontally. So if it's a negative sign, it moves to the right. It's a positive, it moves to the left. So remember, that's kind of like the opposite, because you would think negative is left and positive is right. That's always like the opposite. For your k, that moves it up or down, but with the same sign. So vertically. And then for a, if a is negative, it's reflected over the x-axis. And if the absolute value of a is greater than 1, so it's not a fraction, it's a vertical stretch. And if the absolute value of a is between 0 and 1, so it's a fraction, that's when it's a vertical compression. I'm sure these words are coming back to you now, so we're going to be dealing with the same type of thing. So for example, if we look at f of x equals the square root of x minus 7 plus 2, this minus 7 minus h means that it goes right 7. And then this plus 2 means that it goes up 2. So it's the square root function. So that graph will look like this. So we're going to move that right 7 and up 2. So now it's just starting here, and then it would be 1, 1, and the 4, which will be off the graph, up 2. So our graph would just start there now instead. So we're going to be working with all those transformations. So come to class with any questions that you guys have.